Group 15. My name is Vinny.
I'm Andrew.
And I'm Emmett.
Our project will be using the LEGO gyroscope sensor and the LEGO motor. So the way we plan to do this is by using the LEGO gyroscope sensor to measure an angle. And when the angle is between plus or minus 10 degrees of a 0 point we have determined, the motor will be off. As the angle increases to anything greater than plus or minus 10 degrees, the motor will also increase in speed by a constant increment until the motor is at full power and outputting 100%.
Perfect. Hi, continuing along with the rest of our video, this is a quick demonstration of our apparatus, or in this case, our gyro device. Looking at our device, we have three main components being our gyro sensor, our motor, and our EV3 motor, which serves as a computer that we'll be programming the sensor and motor to. The sensor in this case, which can be seen on the screen, reads an output between 0 and 360 degrees, where by turning it, we will see a response on our angle measurement chart known by or otherwise seen on the waveform chart. Also connected in this, through the computer, through LabVIEW programming, we have the motor set to where when the gyro turns 0 and 10 degrees, the motor remains off. However, when seen by, again, the waveform chart, as we increase past 10 degrees, noted by this, we see the motor turn on, and then as we increase past, all the way up to, as we call 180, we can reach up to maximum power, again denoted by reaching 100% on our power waveform chart of our speed. Moving that back, we can then deaccelerate and come back down. And if my lab partner will come a little bit closer, we can show this process in a little bit greater detail. Going to a closer view of our robot, here we can see a clear demonstration of the gyro working in action. So here we start with the gyro again in the vertical position. We are calling this 0 degrees, as denoted by our 0 degree reading on our angle of our gyroscope. Then between 0 and 10, we see no motion in the motor, denoted by the changing angle between 0 and 10 degrees, but seeing no change in this motor. However, when we increase over 10 degrees, the motor does turn on and we start to see a response connected to our waveform chart's outputting speed. Then as we increase this rotation, we can go clockwise or we can even go counterclockwise. We notice the speed of our motor increasing proportional to the angle that we're going. And in this case, even if we go all the way, mind the limitation of the wire, we can reach eventually full speed around 180 degrees, denoted by our speed reaching a maximum at 100. And then again, this operation can be reversed all the way back down to 10 degrees where it should stop. And then even there's that little gap where between 10, we see again, no movement.
All right, hi all. Now we move on to the third part of our video, which is the LabVIEW code, which is actually directly uploaded into our EVA 3 brick, and it is what's making it operate. So the first part of our code, we see everything closed in this loop, this while loop, which is pinned to true the whole time. So that's just telling the brick to just continuously run everything inside this loop. And next, inside the loop, we have port A and port 1. Port 1 is our gyroscope, so that is wired into the angle. And port A is our motor, which is wired into the speed. So what we have first coming out of the angle is this wire, which is reading the angle of the gyroscope, and it is inputting it into an array, which is then stored, given into the angle waveform chart, and goes into this shift register so that it continues to store all of the angles for each iteration of the loop, and then plotting them on the waveform chart. Then after it goes and plots it, it will go into here. It will take the absolute value so that when there's negative angles, we're just getting the magnitude of the angle for our speed. And then when we have that absolute value, we then perform a little logic. So what the logic is saying is if the magnitude of the angle is greater than 10 degrees, it will return true. And if it's less than 10 degrees, it will return false. Now we have a select. And what we have here is we have, once again, the absolute value of the angle. But here we have it divided by 1.8, and that's to increment the 180 degrees and turn it into a maximum of 100, so that our speed, because our speed is limited to a maximum of 100, it will take the full range of angles and increment it through each angle into a speed measurement. So what we have is if the angle or the absolute value of the angle is greater than 10, it will return true and spit out this 1.8, the angle divided by 1.8 and give that to the speed of the motor. If that's not true, and if the angle is less than or equal to 10 degrees, it will take this 0 and put that into the motor. So this logic is just saying that if the angle is greater than 10, do just kind of apply the angle divided by 1.8 into the speed measurement. And if it's less than or equal to it, it will just have no speed. Then what we do is we take this angle and we do a little more logic right here to say if it's greater than 100, just have 100 go into the speed because the speed caps out at 100, and if not, just input the angle divided by 1.8. And that is pretty much it. Yep.